When you are multiplying or dividing radicals, you only need to have radicals with the same indices. It's okay if the radicands are different, such as in this case, but you must have the same indices. For example, I could not multiply or divide the square root of 5 times the cube root of 20, but I can divide the square root of 5 by the square root of 20, even though the radicands are different. And when multiplying, all we need to do is multiply out the radicands with each other, and then also multiply the coefficients. So the coefficient here is -1, and then this is just 1. So if we multiply the coefficients, that gives us -1 times 1 is 1. And then we multiply the radicands with each other. 5 times 20 is 100. And now we simplify this. Square root of 100 is 10. So we have -1 times 10. And this gives us a final answer of -10. Let's try dividing. When we are dividing radical expressions, again, as long as the indices are the same, which they are in this case, we simply divide the radicands by each other. So this is the same as saying the square root of 20 over 5, which equals the square root, 20 divided by 5 is 4, and the square root of 4 is 2. Let's look at one final example. The final thing that we want to note is that we should never leave a radical sign on the bottom. So if we have a radical sign on the bottom, which we do over here, we want to fix the situation. You can't, this is equivalent to saying square root of 8 over 7, but since that is not an easy number to express, we can't express that any more simply. Let's see what we can do to get the square root out from the denominator of this fraction. I know if I multiply by root 7 over root 7, that's the same as really just multiplying by 1, and anything multiplied by 1 is itself is the same thing. So this solves a few problems for me. Now I have root 8 times root 7 over, and root 7 times root 7 in the denominator just gives us 7, which then can simplify to root 56 over 7, and if you simplify root 56 using its prime factorization, you get 2 root 14 over 7, which is the same as our original expression over here, just with no radical sign in the denominator. So remember, to multiply or divide radicals, you have to have the same indices, and then you simply multiply or divide the radicands together and simplify the resulting expression.